Hello. This practice exercise is just one of the practice exercise that actually involves on the measurements of the angles of a triangle. Take note that we have a triangle angle sum theorem, which tells us that the sum of the interior angles of a triangle is 180 degrees. But this practice exercise is very special, for it is actually concerned on right triangles. In number one, we have here this notation here. So that means a right triangle, as well as in number two here. And in our module, as presented in our module, if we have a right triangle, we can draw a relationship between the acute angles of that triangle. And what is that relationship? Since the sum of the interior angles of a triangle is 180 degrees, and we are already given here with a 90 degrees, so 180 minus 90, that would mean that the sum of the remaining two angles is also 90 degrees. That's already fixed because again, one of the angles is 90. And if they so will sum up to 90 degrees, that would mean that the acute angles of a right triangle are complementary. Again, we do have a theorem for that and presented in our module. So in this practice exercise, we are to solve the measurements of the angles here looking at that relationship. Since this is already a right triangle because of the given here, we can assume that the sum of angle R plus the measurement of angle S is 90 degrees. Because again, because of that theorem, we can say that they are complementary. This is the constant formula for these examples here. So to solve, just simply need to substitute. You have 43 degrees plus the measurement of angle S, which is given to be x minus 20 degrees must be equal to 90 degrees. Our goal here is to solve for the value of x here so that we could also give the equivalent value for the measurement of angle S. So to do that, we need to continue. X 43 minus 20 is plus 23 degrees equal to 90 degrees. And then subtract both sides by 23 degrees. Okay, so we have x is equal to the measurement 90 minus 23 degrees is equal to 67 degrees. This should be the value of x. We do have a checking later, but for us to check this, let us first get the value of or the measurement of angle S. And whatever will be the result for this, we will use it in a form of, and we will use that for our checking. The measurement of angle S is given to be x minus 20 degrees. So I need to substitute the value 67 degrees minus 20 degrees. The measurement of angle S should be 47 degrees using the computed value here. So this is the result after we substitute our computed value for x. But we are not yet sure if this is correct. Also, this is we are also not sure if this is correct. To do that, we will use checking. And how do we use checking here? We could actually check in two different forms. We could combine all of the angles here, okay? They must sum up to 180 degrees. Or you could just simply use the relationship drawn here that they are complementary. After all, we have proven that theorem already. So the measurement of angle R, which is 43 degrees, plus the measurement of angle S, computed to be 47 degrees, should sum up to 90 degrees as they are complementary. If we can show that these two sides are the same or correct, that would mean the measurement of angle S is correct, and ultimately the value for the computed value for x is also correct. So 43 plus 47 is 90 degrees is equal to check 90 degrees. Now we have checked that this is correct and ultimately this is also correct. So this is how we solve problem like this because we already have a theorem for that stating that in a right triangle, the acute angles are complementary. We are sure that the angles, not the non-right angle except for this, are acute because if one of them are obtuse or right, we cannot come up with a triangle. Please take note of that. So let's try to use the same concern as we proceed to number 2. We are to solve here the value for x so that we could get the measurement of angle L and angle N. The difference with this problem to number 1 is that in number 1, one of the angles are given with a measurement, is given with a measurement rather. Here, none of them is given a measurement. So how do we do this, sir? Again, we will just simply go to the theorem stating that the measurement of the acute angle L plus the measurement of acute angle N are complementary or must sum up to 90 degrees. So let's use this formula and substitute the given here. We have 2x plus x minus 9 degrees must sum up to 90 degrees. And apply only the properties of equality. You have here 3x minus 9 degrees is equal to 90 degrees. Then we add both sides by 9 degrees. Right? So we will have here 3x is equal to 90 plus 9 is 99 degrees. And then we divide both sides by 3. So our value for x should be 33 degrees. Again, we are not yet sure if it's correct or not. So we will still check it later on together with the value for the measurement of angle L and angle N. So let's use this value to get the measurement of angle L, which is represented by 2x. That is 2 times 33 degrees. So this must be equal to 66 degrees. For the measurement of angle N, which is given to be x minus 9 degrees, it is 33 degrees as given here, or computed here rather, minus 9 degrees must sum up to 24 degrees. Is it correct? 33 minus 9 is 24 degrees. So these are the values using the value of x here. To complete our process, let us use checking. Again, checking is not necessarily important later on in your solution, but it's an important skill to master. So how to check? We will always use the given equation as this is the claim of the theorem stating that the acute angles of a right triangle are complementary. And simply substitute the computed value here that's 66 plus 24 for the measurement of angle N must be equal to question mark 90 degrees. Sum them up 66 plus 24 that's 90 degrees. Check 90 degrees here as well. Now that we have balanced the equation in our checking, that would mean this is really the measurement of angle L. This is also the measurement of angle N. And the value we use to get those two measurements for x is also correct. So this is how we solve problems pertaining to angles of a right triangle. As for sides, they will be discussed soon in the next grade level. So please keep on practicing and reviewing this so that you could actually use this later on in your assessment. Goodbye, everyone.